So good evening everyone. Today we are going to solve one of the GATE 2019 question. So this came of 2 marks. So as I say, first we need to know what and all the reagents are there and what is a functional group here. So the first reagent is PCC. So PCC is basically pyridinium chlorochromate. So PCC is basically oxidizing agent, right? So CH3, and we'll just write the starting material here, CH3 and CH2 and OH, and you have your PCC here. So the main function of pyridinium PCC and oxidizing agent is you are converting your primary alcohol to aldehydes, right? So what does an oxidizing agent do? It converts an alcohol or anything, oxidizes it. So this is your primary alcohol. When it is oxidized, it forms this is your aldehyde, right? So I think the first step, what and all you want, it's there. Now what they have given you is zinc bromide, right? C double bond OH, and when you are writing zinc bromide is like this, right? So this, the lone pair of oxygen will attack on the zinc and the bromide will go. So we can write the product as like this, CH3 double bond CH2 CH3 CH2 C double bond O, zinc, Br and H. So basically we can write it this as like this, right? There is another form where we can write this. So I think I'll write it like that. So when we write it like this, so it will be, right, you have your C double bond O plus zinc, Br like this, and your CH3 is the plane alpha, and your CH3 is like this, right? So this is a simple metalloene reaction, So what happens here is, we'll just name it first, 1 2 3 4 5. I think somewhere we missed it. So when we name it 1 2, I'll name it like this, 1 2 3 4 5 6 and 7. Okay, So we'll write it like this: CH3 and CH3. So this is 5, 6 and 7. So as I said, this is a simple metallo reaction. So here your CH2, this H will migrate this side, this it will shift and it will go like this, right? So when we do, how come it will be simple 6-membered ring? Your CH3 will be like this only. You have your CH3 here, your double bond CH2 and O, right? Then Zn Br, then hydrolysis plus it will the migrating H only. So when it will go, you have your OH, right? OH CH3, and this will see, as we know, the more stable form of cyclohexanone is, it will always occupy, the bulky groups always occupy the equatorial position. So your OH is also will be in the equatorial position, your this ene will also be in the equatorial position. So when you try to name it, let's see, 1, 2, 3, 4, 5, 6. So I'll just draw. How do you draw this structure? I'll just draw, show you. So you have your 6-membered ring here, right? You have your CH3 here, you have your OH here. I think this will be CH2, right? CH2. So you have your CH2 here, right? Yeah, this is the only thing. But how will be the planes? So your CH3 is alpha, we can write it like that, it's in the CH3. So the 1 and the 3 are equatorial to each other, that is trans equatorial and equatorial. So we will write it as like this. I don't think so. OH and your 1 and 4, which is this is like this, sorry, and this will be in the back of the plane. So I think we can, I am rewriting it again. CH3, you have your OH here, C double bond. I think the answer is C. So we can say C is your answer.